Now there's one more thing to really understand before you go ahead and start drawing graphs, and it's how they change. So what I'm going to do here is show you 6 graphs, one after the other, and I want you to maybe pause it and try and come up with as many differences as you can. Now what I like to say to my pupils at school is, those of you ever been to Playzone, think about the red slide. Every Playzone has a red slide. If you've ever been on it, think about that. Any hills that you have in your local area, or ever been skiing, how do the different ski slopes change? How do hills change? How could you describe a hill to someone? Think of the words you would use and think how you can use it here. So there's the 6. Start looking for all your patterns. Now, you should be able to see that these 3 are all starting in a similar direction, well, going in a similar direction I should say. So bottom left to top right, again, so bottom left to top right sort of, and a very steeper one. And these are all going in the opposite direction. So we say these are going in a positive direction. Oh, sorry, I didn't mean to do that. These are going in a positive direction, these 3, and these are going in a negative direction. Now, do not confuse this with correlation. Correlation is when we have scatter graphs. This is a straight line. It means there'd be a perfect correlation, so we don't use it. So we say it's a positive direction, and these bottom ones are a negative direction. The other thing I need you to see is that the steepness changes. This being the steepest graph, and this one probably being, or this one, either of these two, being the least steep. And we'll go into a bit more of that in the later videos. And also, they cross the x and the y axis at different points. Now, every single graph that we'll show you will always cross the y axis. Now, every graph always crosses both, but this one you can see it hasn't, but it will eventually cross the x if I extend this line. So with straight line graphs, we're only ever interested in where it crosses the y axis. So this one's -5. This one's -6, this one is 0, this one is 4. So, by exploring graphs, you need to understand that the y and the x are simply the coordinates. The m is a letter that we use to represent, funny enough, a word not beginning with m, the gradient. Probably because g has already been taken in science for gravity, so we use m for gradient. Now, this is a fancy, more mathematical word for steepness. Although they're not quite the same, we use it in maths to describe the steepness of a line. So this is y equals 1x. If this line is positive, it will if this number is positive, it will always go in these directions. However, if I change our m to a negative, it will then go in any of these directions. You should be able to see it's the opposite. Now, the higher the number, the steeper this graph will be. So if this is like a 10, it's going to be a lot steeper than a 1 or a 2. So the higher this value, the steeper it is. Now, that's easily confused with negative numbers. What we'd actually say is 5 and -5 has the same steepness, and we don't look at 5 being a higher number than -5. The 5 part is telling us the steepness, the negative part or the positive part would tell us the direction. And the C, the bit on its own, the bit that's not connected to the X, that is what we call the y-intercept, where it's going to intercept or cross the Y. So take a look at this and look at the red dot, and I'm going to move this graph up or down. So you can see that red dot moving, and that's because the y-intercept is changing. So where it crosses this is what we call the y-intercept. So you need to be able to look at a straight line graph like this and say which is the gradient and which is the y-intercept. So this means it's with a 2. So this is the gradient because it's the bit with the x. That means it's a positive number, so it's going in the positive direction. And 4 is the bit on its own, not directly with the x. You could say it's attached, but not like this. It's not together with it. It's separated by a sign. So that means it's crossing the y-axis at 4, so up onto 4. This one means this bit is with the x, so the gradient is a -3. So 3 means it's a steeper graph than this, and because it's a negative, it means it's coming down in this direction. So that's the gradient, and the bit without the x, the bit on its own, is the 1, means it's a y-intercept at 1 on the y-axis. These are trickier. So the bit with the x is not this, it's here. Now a lot of people learn it's always the first number is the gradient. It's not. It's the bit with the x. So that means it's a 3, positive direction. And the 5, the bit on its own, is also a positive number. So that means it crosses the y-axis at 5. Again, here, this is the bit with the x, so that is the gradient, which means it is a less steep graph than this one because the number is smaller, and the negative means it's going downwards from top left to bottom right. And the bit on its own, this is a positive number, this is an 8, not a -8, so it means it crosses at 8. So using this knowledge, we're going to try and match up some graphs. So you can see here that we have 4 graphs. 1, 2, 3 are going in the positive direction, and this one's coming down in the negative. So let's start with that. Which one of these has a negative with the x? Well, it's this one. So that must go there. Now, 1 and 2, these have the same gradient of 2, and this is technically a 1x, so we can separate these gradients. And if we look at the y-intercepts, we can also separate these. So let's have, and this one you can see is -1, and it crosses at -1 also, so that one's finished. So this one, we can see here that these both have a 2, which means they are steeper than this one. So if we look at these 3, you can see that these 2 are quite steep compared with this one. This one is definitely less steep. If you were going down a ramp on a bike or a slide or whatever, this one would be a lot faster, well these 2 would be a lot faster than this one. So now we know that these 2 have the same gradient, the same direction, the same steepness, but we can see here that the y-intercepts are different. So this one has a +2 and this one has a -5. So which one crosses at +2? This one. And this one therefore must cross at -5. So there we have it. So I first did it by looking at the gradients and the direction and the steepness, and then we compared the y-intercepts. You don't have to do it that way. Some people like to start with the y-intercepts. These 2 are the same, so you'd have to look at the differences then between the gradients. And get good at this before you even start to draw a graph.